Okay, so I want us to work on this high order questions. Now look at this question. This is from KwaZulu-Natal past paper. And this is what we'll be eating on this lesson. So we'll be eating angle theta one way. Okay, why is this thing moved? All right, so let's work on this, guys. Let's see what we can do from this question. I'm going to first start with the first question, and I'll definitely take this step by step and make sure that if there's something you don't understand, pause the lesson and try to make sense out of whatever that you are confused with. So if sine 38 degrees is P, determine the value of the following. Guys, before I even go to this 6.1.1, there are some of the things that I need to do. So I'm going to rewrite that sine 38 equals to P and do my magic. Let me go and do that and see what I can do from that part, okay? Okay. Let's see. If you check, this is question, what was that question? This is question 6, okay? So on this question 6, I'm going to first rewrite everything that was given on that side, and then I'll take it from there, okay? Okay, so now when I look at this question, we are saying that we are given the sine. Let me just verify this. The sine 38 is equal to P. So this will be the sine 38. This is what I'm given. The sine of 38 degrees. This is equals to P. So remember, any number, any variable, it's over 1. Okay, so I'm going to introduce the soccer tool. Okay, so if you still remember the soccer tool, it tells us that when you are working with sine, sine its opposite, which is y, over hypotenuse, which is r. So on this problem, the given problem, we are given y to be p and we are given r to be 1. So what is missing? Let's draw the diagram first so that you can understand what is going on. And you also need to ask yourself, in which quadrant are we going to put our diagram? Right, I'll explain that now so that you can understand which diagram to use. Okay, looking at this will be my 0 degrees. This is 90. And I'll have this as 180. Then this is 270. The last one is 360. So where should I put my diagram? You're going to look at that angle, 38 degrees. So 38 degrees is between 90 and what? And 0, which is quadrant 1. So my diagram should be in quadrant 1. So I'll definitely put my diagram in quadrant 1. So this will be my diagram here in quadrant 1. And this is 90 degrees. This angle here is 38 degrees. So now, when that angle is 38 and this is 90, what will be that other angle? So this is something that you need to ask yourself. If this is, remember, the sum of angles should end up to what? Should end up to 180. So you're going to say 180 minus 38 minus 90 to find that angle. So what I'm trying to say is that that angle will be 180 degrees. You minus 90, you minus 38. Sum of angles in a triangle, and it will give us that angle to be 52 degrees. Right, I hope you understand how I got that one. Okay, so now we are given y, which is the opposite. They say y is p, and we are given r, which is the hypotenuse, it's 1. What is missing? We are missing x. So I'm going to use the theorem of Pythagoras to find x. Before you answer the question, make sure that you have x, y, and r. So I'm going to use theorem of Pythagoras. So it says that r squared is equal to x squared plus y squared. Okay, so now let me just substitute what I'm given. I know that r is given as 1. This is squared. X squared is what I'm looking for, plus y, which is p. So this will be squared. So I'm going to take the p squared to the other side. This is 1 minus p squared is just equal to x squared. So this is x squared. So now look at this. I have 1 minus p squared, which is equal to x squared. I'm just going to square both sides. Therefore, x it's plus or minus the root of what? The root of 1 minus p squared. Then you need to decide if your x is positive or negative. And how do you decide that? You look at the quadrant that we have our diagram, which is quadrant 1. All the x values are positive in quadrant 1. All the x values are positive. Therefore, I'm going to conclude and say x is equal to the root of 1 minus p squared. So that's my value of x. Okay, so why is it important that you say plus or minus? Because let's just assume that let us assume that the diagram was in quadrant 2. So the x was going to be negative root of 1 minus p squared. I hope you guys understand that one. Now that you have everything, you can now start answering the question. So now what you need to ask yourself, how do you know if you have everything, if you are ready to attempt to start attempting question? First thing first, make sure that you have all the sides. This is 1 minus p squared. All the sides of that triangle, you need to know all the sides. Right. Now let's go and answer the first question. The first question says they want us to find the cos 218. Okay, the cos 218. So now, what I'm going to do is that let me just close that guy because it's going to disturb us. Okay, so you know what I'm going to do to answer this 6.1.1. So they are looking for the cos of 218 degrees. Okay, so now I need to reduce this angle because when you work with this, make sure that it's either your angle is 38 or 52. So if it's not 38, if it's not 52, do not use that triangle. So you need to first reduce that. So how can we reduce the cos 218? We're going to check in which quadrant is that angle. Okay, so the cos of 218, it's in quadrant 3 because it's between 180 and 270. So what is going on in quadrant 3? 180, and if I move in that direction, I'm approaching 270. How do I approach 270? By adding theta. So this tells you that I'm going to say this is 180. I'm going to add something. What should I add to find 218? So I'm going to share my calculator now with you guys so that you can understand how this works. Okay, so you're going to say that this will be 218. You subtract that 180, then you'll know what you need to add there. This gives us 38, you see. So this tells you that we need to add 38. So if you add 38 degrees, that will give you 218. Then you do the reduction formula. Where is cos 180 plus 38? It's in quadrant 3. How is cos in quadrant 3? Cos is negative. So this will be negative the cos of that angle, 38 degrees. Then to solve this will be negative the cos 38. We're going to use the diagram to understand what is cos 38 equals to. Now that the angle, we have it in that triangle, which is this 38. So if I'm using that angle, this is my opposite and this is my adjacent. Because remember, the 90 degrees, it is formed by opposite and adjacent, and this will be my hypotenuse. So if I'm using angle 38, my opposite is P, my adjacent is the root 1 minus P squared, and my hypotenuse is 1. So I'm going to say that according to SOHCAHTOA 2, cos, it's the cos of theta is going to be adjacent, which is x, over hypotenuse, which is r. Okay, so now this will be negative the cos of 38. So you need to understand what is your x. We just calculated x to be the root of 1 minus p squared. We're going to divide this by r, which is 1. So that's your answer. You can just write this and say This is negative to the root of 1 minus p squared. Then now you can move to the next question. Go and collect that next one. So I need you to try and work on 6.1.2 and leave a comment. I need you to be honest and tell me if you've managed to get the same answer that I'm going to get when I do 6.2. I need you to be honest. Pause the lesson, try and work this one on your own. Let's see if we get the same answers. And please comment your answer. I need to see your comments, guys, coming there. So let's see who's going to get this one right. So they say we need to do the cos of 14. So 6.1.2, the cos of 14. Now I'm in an exam, and then now I have so much stress. I'm panicking. My angle is 38 and 52. What does this has to do with 14? You just have to think about it. How can I bring 52 and how can I bring 52 and 38 from that 14? Look at what I'm going to do. I also don't know which angles I'm going to use, what can be done from that. And I need you to look at what I'm about to do. So I'm going to open my calculator, and then I'll start pressing numbers. I'm gonna just press any number, say 90 minus 38. You see, 90 minus 38, that's 52. So I see that, okay, 90 minus 38 gives me 52. Then let me try and something. What is 38 plus that 52? What do we get when we add the two? What do we get? You see, 90. But what about if I say 52? What about if I say 52 minus 32? What should I get? 52 minus 38, and then this gives me 14. Oh, nice. Now I have the 14 that I'm looking for. And then look at this. I know that I can write this. As you see, I just go on the calculator, punch, try to relate the 38, the 52, and the 14. So I know that we will get 14 if we say the cos of 52 degrees with minus 38. So now I'm happy that these are something that I have on the triangle. But how can we do this? This is a compound angle. This is a compound angle. We are subtracting two angles, and this will be the compound for what? For cos. You go to the formula sheet, you write down the formula for a compound for cos. You're going to write down your formula. You're going to say that if I have the cos of alpha plus, oh, we are subtracting, right? So we're going to subtract the cos of beta. What is that equals to? It's equals to the cos alpha, the cos of beta, and then the sign changes from negative to positive. You don't have to stress about this. Just go to the formula sheet, get this formula from the formula sheet, then you'll be good to go. So now from this formula, I can just substitute what I have. I can just substitute what I have. So I'm going to just substitute this and say, I know that I can let my alpha to be 52 degrees, my beta to be 38 degrees. So where there's alpha, we're going to put, where there's alpha, we're going to put 52, and where there's beta, we put 38. This will be the cos of 52 degrees multiplied by the cos of 38 degrees. Then I'm going to add the sine of 52 degrees times the sine of 38 degrees. You see, this is something I can work on because I can use the diagram to find all these things. So look at this, the cos 52. Let's first start with the cos 52. Remember, the cos is what? Now I'm going to change some of the things here. Look at what I'm going to do. Which mark? Okay, I'm just going to use the blue one. So the blue one is when we are using the angle 52. Oh, that's not good. Let me just try to find another strong marker. Which one should we use? Okay, the red one. I think that one can work. So if I'm using 52, which is that angle, the side that is opposite to that one, it's this one. So this one it's opposite. Remember, green is when we're using the angle 38, and red it will be when we're using the angle 52. Because you need to check if this is 52, which one is your opposite. The side that is opposite to that angle 52 is your opposite, and which makes this one to be the adjacent. Right. I hope you guys understand, and I hope you understand how this works. Né? So now what I'm going to do, the first one is the cos 52, and cos is adjacent, which is x over r. So if I'm using 52, what is your opposite? What is your adjacent? So 52 is red, right? So if 52 is red and we are looking for the cos 52, that will be x, which is adjacent. The red adjacent, it's P. So I'm going to say this is P over, and then I have R, which is 1. So this will be P over 1. I'm very sorry, guys, for going up and down. Eh? And then this is multiplied by the cos 38. Remember, 38 is when we are using the angle 38, and my opposite is the green one. Okay, so the green one, 38, this will be the cos of 38, which is adjacent. The adjacent, the green adjacent, it will be root of 1 minus p squared over 1, which is r. I hope you guys are following that. So this will be the root of 1 minus p squared over r. Then close the bracket. Now I'm going to add the sine 52. Right, so if we do the sine 52, 52 rate. Sine its opposite all over hypotenuse. Which one is the rate? The rate is the opposite, right? For that 52. So it will be root 1 minus p squared. So this will be plus the root 1 minus p squared over 1. Then now I'm going to multiply this with the sine 38. Let me not stress about sine 38. Remember, sine 38 was given as p. So it's just P over 1. So I'm going to say this is P over 1. Guys, if you can manage to do this substitution, I'm telling you, from here, everything becomes more easy because you just have to multiply the numerator. So this is like saying this is P root 1 minus P squared. Then we add this with what? With P root 1 minus p squared. Look how beautiful this equation is. These are like terms. So if we add the 2, we just get 2p, the root of 1 minus p squared. That's your answer. You can just leave it like that. Wow. Okay, let's move to the next question. Let me see what we have on the next question. And now let's work with the sine 26, the cos 26. Right, I'm just going to write that down, and then I'm going to train you how to work around that angle. I think this one is going to be the easiest one. Let me just put it down here. So on this 6.1.3, we need to work on the sine 26 degrees and then the cos 26 degrees. Guys, remember, you need to think. And when I say you need to think, don't think outside of the exam. Maybe like you are thinking about something else, maybe something happened yesterday, what. Think about what you are looking at, which is the sine 26, the cos 26. So that's how you pass maths. When you are writing maths, just forget about what happened yesterday. Just forget about the problem that you did and you are struggling with. Focus on what you have now. Look at this. The sine 26 cos 26. How can I bring 38 and 52? Either one of them or both of them. How can I bring them to this equation so that I can use that diagram to solve this? What should I do? That's what you need to ask yourself. And then now look at something here. So when we say that the basics are very important, this is what we are referring to. Bonafide, the sine, the cos. What comes in your mind when we work with trigonometry and we have the product of sine and cos? So I know that sine of theta times the cos of theta. This is an identity, but I'm missing something. This should be 2, and this is equals to what? This is equals to the sine of 2 theta. Wow. You see, the sine of 2 theta. So now the difference is that the angle are the same. Yes, that's good. But now I don't have 2. I can't change this into the sine of, you see, I don't have 2. So let me show you if how to work around that problem. So I'm going to divide both sides by 2. Divide both sides by 2. Therefore, this tells me that where I see the sine of theta multiplied by the cos of theta, I can substitute that with 1 over 2, the sine of that 2 theta. So what I'm trying to say is that I can definitely change this equation and write it in this form and say this is half the sine 2 of that theta, which is 26 degrees. On your calculator, just say 2 times 26. You'll see the magic. What do we have? 1 over 2, the sine of what? 1 over 2, the sine of 52. You see, this is nice. We know what is the sine 52. Even if you can just refer to your previous questions that you already worked on. Look at this. The sine 52, it was that. So I can just substitute that on this equation. Then I'm done. So this will be 1 over 2 into the root 1 minus p squared, and this was over 1. So that's your answer. The answer is just half root of 1 minus p squared. Easy. Okay, I think I've said much on this question. I think I gave you guys strategies how to work around this question. Focus on what you have, okay? Focus on what you have. Let's move to the next question. Evaluate the following trigonometric expression without using a calculator. Guys, you see, they even write this in bold without using a calculator. And when I will be like, you know what, this is my calculator again. So I'm just gonna punch the calculator. It's fine, you can punch the calculator, but let me teach you what to do so that they don't see that you use the calculator. We'll definitely work on that, okay? Just give me a second. We're going to solve this problem and we're not going to have any problems, okay? So let's work on that. I'm just going to take the given problem, I'm gonna rewrite it on the other side, then we'll start working on it. Okay, so I'm given 6.2. Okay, so on this 6.2, the problem goes like this. They say this is 2 the sine of 2. This is 2 the sine 165 degrees. And then we multiply the cos 195 degrees. So everything here is divided by, okay, everything is divided by the cos 45 multiplied by the sine 15 minus the cos 15 times the sine 45. So now when I see a pattern on bottom left. If you still remember, look at this. Cos alpha, cos beta, sine alpha, sine beta. You see? So the cos alpha, the sine beta. So the angle that is on cos, it should be the same on the angle that is on sine. The angle that is on cos is the same as the angle that is on sine. Look at this. This is what I have. The cos 45, the sine 45. So this is a what? This is a double angle for what? This is a double angle for sine. I hope you understand that. And if it's a double angle for sine, oh, this is cos 45, sine 15. So is different to this one. Eh? This one was for cos, and then I'll definitely write it down with the one for that sine. So let me quickly remind you what it looked like. So this will be, since this one is negative, We know that it will be for sine, but you just have to go on your formula sheet, verify everything. You'll see that this is the compound for sine. So this will be the sine of A, then minus B. It's equals to the sine of A. Okay, it's equals to the sine of A, the cos B. Then the sine remains the same, and this will give us the cos of A, the sine of B. Right. So this is a multiplication. So this is a multiplication. I'm going to just leave that the way it is because it is in the form that we need it. So everything is good on that side. So the only thing that I can arrange maybe is this one, the cos 45 and the sine 45, and write it in that form as sine A cos B, cos A sine B. It's fine, but since it's the product, the order doesn't matter. When I say the product, 2 times 5 is the same as 5 times 2. Both of these gives us an answer of 10. So this tells you that the bottom part, everything on the denominator, I can write everything on the denominator as the sine of A, which is 45, then you subtract B, which is 15. So I'm going to substitute everything on the denominator and part. But now I have some of the things that I need to fix on top, which is doing the reduction formula. I have a very big angle, 165. I also have 195. So I need to reduce those two angles. Okay, let's talk about how we can reduce the angles. Let's start with 65. Let's start with the sine 165 degrees. In which quadrant is 165? That's what you need to ask yourself. If I have a Cartesian plane like this, I know that this is 90, this is 0, this is 360, then this is 180. Look at this. 165 is between 90 and 180. So it's in quadrant 2. So if it's in quadrant 2, how do I move from 180 to 90? I subtract. So I can write this as the sine of 180. What can I subtract from 180 to get 165? I need to subtract 15 degrees. Okay, so now what you're going to do, you ask yourself, how is sine 180 minus 15 in quadrant 2? Sine is positive. This changes into the sine of 15 degrees. So this tells you that when we do the reduction formula, where there's this sine 165, I'm going to substitute that as sine 15. By writing sine 15, you have a mark. They'll definitely give you that mark. Then now I need to also reduce the cos 195. So I'm going to say the cos of 195 degrees is equals to, in which you ask yourself, this is how you do the reduction. Ask yourself, where it's 195? It's between 180 and 270. Okay, so since it's between 180 and 270, you're going to ask yourself, how do I move from 180 to 270? I'm going to add. So this will be the cos of 180. I need to add something to get 195. So we need to add 15 degrees. So then you're going to ask yourself, how is cos in quadrant 3? Cos is negative. Let's change into negative the cos of 15 degrees. So what I'm going to do is that where I see this cos 195, I'm going to sub in that by negative the cos of 15 degrees. Wow. Let me just rewrite everything down and let's see what we have so far. So this will be 2 the sine of 15 degrees multiplied by into the bracket negative the cos of 15 degrees. So everything here is divided by, if you still remember, we said on bottom, we're going to write that as the sine into I think we talked about, let me just look at the compound angle, I just want to confirm something, okay? Okay, so I think I did confirm that compound. Let us continue with this one. Okay, so now we said on bottom we're going to write this as the sine of 45 degrees we minus 15 degrees, right? Then what do we have on top? So let me arrange the top part. This will be negative 2 the sine 15 degrees, the cos 15 degrees. Then everything is divided by the sine 30, the sine 30 degrees. Okay, and look at what I have here, okay? When I look at what I have here, remember we talked about that the sine of 2 theta is equal to 2 the sine theta times the cos theta. And this is what we have, the sine theta multiplied by the cos theta. But this time, this one is that 2. So we can change this part here. We can change this part and write it as 2 times, okay, sine, or let me write it down. So we can change this part and write it as negative 2. The sine of 2, our angle is 15 degrees. Everything is divided by the sine 30. Okay, so this is equals to negative 2, the sine of 2 times 15, that's 30. And then I'm going to divide everything by the sine 30. So the sine 30 cancels, and this leaves me with an answer of negative 2. So when I solve this, I get an answer of negative 2. Right, and that's it for this question. So this 2 cancels, then this leaves me with an answer of negative 2. Okay, let me go to the next question, number 6.3. Okay, so 6.3, we are given k to be equals to the root 3, the cos x plus sine x, and write k in the form of t into sine of x plus theta. Guys, look at this, né? Look at this part. Look at this part. I'm going to remember I said focus on what you have. I have the sine of 2 angles that where we are adding 2 angles, okay? And if we are adding 2 angles, this is a compound angle for what? For sine. So if I have the sine of alpha plus beta, this will be equals to the sine of that alpha, the cos beta, and then the sine remains the same. This will be the cos of alpha, the sine beta. Right. So I can change this guy here, write it in that form. Okay. So I need to say whatever that I do, I need to, this thing, it is in that form. So basically what they did on that, they reduced this and write it in that form. Then they have a certain value there, which is t. So how can I put this k in this form? Okay, how can I put this k in this form? Then from that form, okay, let me just, I don't know how to explain this, but let me try my best to explain this. So we're going to start with, we need to change this guy. We need to change this guy and write it in that form where we're going to have sine times cos. We only have cos, we only have sine. So we need to change it and write it in that form where we're going to have sine and cos, cos and sine. So how can we do that? First thing first, look at this. This needs you to be familiar with the special angles. Okay, this needs you to be familiar with the special angles. So I know that on the special angles, when I have the root 3, I can divide that root 3 by 2. And what is that equals to on the calculator? That is equals to the sine of 60 degrees. I'm not sure if you guys understand what is going on. So I know that root 2 over 2 is equal to sine 60. So from this question, How can I bring the 2? I can just say, uh, if I multiply this, it's like saying I can take out that invisible 2 out as a common factor. I'm not sure if you are following, but let me try and write this down on the other side, okay? And we'll take it from there. So what's going on here is that we said that uh, the sine of alpha plus beta, it's equals to the sine alpha, the cos beta, the sine remains the same, the cos beta, the sine of alpha. And what are you given? I'm given k to be equals to the root 3, the cos of x plus the sine x. Okay, so now when I look at that root 3, what comes in my mind is that where we have root 3, this has to do with the special angles, the special triangle. So I know that I can create root 3 over 2 from that special triangle. But now, how do I bring the 2 here on this guy? How do I bring? I can write this k in this form. Say 2 out as a common factor, and then inside the bracket, I need to put the number that when I multiply it with 2, it will give me root 3 the cos x, which is just root 3 over that 2. Right. The reason I need this is that I need to sub in that as the sine of 60, which will be the sine of alpha. I already have the cos beta, which is the cos x. So I'm going to multiply this by the cos x. So I think this is high order question. If you don't understand this one, you don't have to stress, because this type of questions, they change every year. If you don't understand this one, just relax, don't worry about it. Let's just do this for fun. Okay, so now the sine x here, I need a number that when I multiply it with 2, it gives me sine x. So that number, it will be 1 over 2, because 1 over 2 times 2 is just 1, which we multiply this by sine x. So this tells you that if we multiply out the bracket by that 2, it takes us back there. I hope you guys understand. And we know that 1 over 2, that will be what? 1 over 2 is the cos of 60. So let me just try and re-explain this question, because guys, I have all the time. I can just explain this even 10 times until you get it right. So look at this. We created the cos of alpha, which is the sine alpha, which is the sine 60. Then when I look at this, I already have the sine. I need to create the cos. So I know that to get the cos, I'll get it if I say the cos of 60. And I know that the cos of 60 is just half. I hope you guys understand that part. Remember, if you don't understand what is going on the question, don't stress, just relax. This type of questions, they change every year. This is high order questions. That's why I chose to work on this paper, because I saw a lot of interesting questions here. So now what's next? What should we do now? What I'm going to do now, k, this will be k is equals to 2. Root 3 over 2, I know that I can substitute that as what? The sine of 60, and then times, this is the cos of x, then plus 1 over 2, I can write that as the cos of 60 times the sine x. The aim is to have this. So if we have this, we can write this as k is equal to, they want us to write it in the form of t into sine of x plus beta. So this will be 2, which is t, into the sine, then we add the angles. What are the angles? 60 and x. So we're going to say 60 plus x. Then you're done. You just have to leave it like that. You are done. This is in the form of 2 into the sine of x plus theta. Nice. Okay, and then you can just leave it like that. Next question, write down, okay, hence calculate the value of t and q. When they say calculate, they are definitely confusing you. Instead of calculate, they want you to determine. So we know that this is t, where there's t, that's 2. Therefore, to answer that 6.3.1, we're going to say t is 2. And then x, that's 60. Therefore, the value of x, that's 60 degrees. Simple. That's how easy the question is. Next question. Write down the maximum value of k. Okay. The maximum value of k, guys, look at this. When they want you to write down the maximum value of k, uh, when we look at this carefully, you know what I'm going to do. I have 2 the sine of x plus 60, right? And this is like what is this? Trigonometric function for sine. So the trigonometric function, the standard form, it's in the form of a, the sine of theta. What is a? So basically the x plus 60, that's your theta. Your a is 2, which is the amplitude. What is the amplitude? It tells you the maximum value because the graph of sine looks like this. So when it looks like this, it's going to start at 0, then it moves up like this. So the value of a is the amplitude. So this point here is 2, which is the maximum value. That's why this question is 1 mark. So the maximum value is 2, which is the value of A, the amplitude. So to answer this, 6.3.3, we're going to say the maximum value is 2. Simple. Wow. I think we've been working on this for the past 40 minutes now. This question paper. This is a very nice one. Next question, 6.4, it has to do with identities. So I'm going to rewrite the identity. Just for fun, we're going to work on 2 methods to solve this one. We're going to work on it 2 methods. Then it's up to you which method you prefer. Also, please make sure that you leave the comment, because now when I say make sure that you leave the comment, I need to see who watched the lesson up until we do 6.4. So let's find all those learners who watched the lesson until 6.4. Right. So now when I'm done solving this, guys, I need you to comment, tell me which method you prefer. Which method it's easy for you. Just put on the comment section, say method 1 or method 2. So let's see how many of you stayed until 6.4, because I know that most of the time when it's like, when you say that, hey, this question is too much for me, you just pass and go to the next video. But let me just work on this. So I'm going to rewrite the question and I'll definitely start working on that. So I'm given that the identity on that 6.4, it's given as the tan, 2 tan theta. Then we subtract 2 the sine of theta. Everything is divided by 2 the sine squared theta. Okay, so let's start with method 1, and I'm looking forward, guys, to your comments. So method 1, this is what I'm going to do on the first method. Let's first change, this is not sine theta, this is sine 2 theta, né? This is sine 2 theta. So first thing first, where there's tan, I know that I can write this as sine theta over the cos theta. That's what I need to change first. And this is an identity. Remember, so what I did on this one, where I see the tan of theta, I substitute sine theta over the cos theta. Where I see the sine 2 theta, that's 2 sine theta, the cos theta. So let's quickly substitute that other part. So this will be minus 2 sine theta, the cos theta. Then everything is divided by 2, the sine squared theta. Right. So the first method that I want to show you guys is that uh, when I have something like this, I can say that uh, focus on what you need on top. Okay, focus on what you need on top, which is on top I need to have only sine. Okay, so I'm going to solve this by inspection. When I say by inspection, it's like saying you are trying to cook something. You understand? So look at this. I'm trying to cook something there, and when I'm trying to cook something, this is what I'm going to do. I know that I have something in common, which is sine and sine. So if I take out the sine out as a common factor there, one sine will cancel that one sine on the denominator, and then on top I will have I'll be left with no sine. But if I'm left with no sine, how can I bring back the, you see guys, I it's, how can I bring back the sine? That's what you need to ask yourself. I can bring back the sine if I have 1 minus the cos squared x. Oh guys, sorry, I'm not just trying to be like maybe playing with your mind or trying to act smart or something. This is how I need you guys to think. I'm saying that on top I have sine, okay? So I know that if I can get to a point that I have 2, if I get to a point that I take that 2 sine theta out as a common factor, okay? If I take out the 2 sine theta as a common factor, that sine theta on top, it will cancel 1 of sine theta on bottom, and the 2, it will also be cancelled because we are trying to prove that this is equal to the tan of theta. Right, so we are working on left hand side now. I hope you guys are staying with me. So now I'm saying that if I get rid of sine on top, how can I bring back the sine? The only way to bring back the sine is if we have 1 minus the cos squared of theta. This is equals to the sine squared theta. Then that's when we're going to also cancel that remaining sine on the bottom. Nope. Okay, it's fine. Let me just do what I'm saying. So now I see that I have this cos on the denominator. I need to get rid of that cos. And I need to have cos squared. So I know that if I can multiply both by cos and bottom by cos, I did not change anything because I need to get rid of that cos. So I'm going to first take the cos, which is the one on top. Then I need to multiply the 2 of sine theta over the cos theta. Then minus, we take that cos again. We're going to multiply the 2 sine theta, the cos theta. Right. Please, if you don't understand what's going on, just wait for the next method. Maybe the next method is for you, né? And then I'm going to divide everything. This times that is 2 the sine squared theta times the cos theta. Right. So now look at this. This is what I was trying to explain, is that I'm solving by inspection. So I know that these 2 cancels, and this times that will give us the cos squared theta. Right. Let's rewrite what we have now. So I'm going to say I'm left with 2 sine theta on top, 2 the sine of theta. We minus what? We're going to minus 2 the sine theta, the cos squared theta. Okay. Then on the bottom we have what? On the bottom we still have 2 sine squared theta times the cos theta. So you check what you have on top. On top, I said we are creating 1 minus the cos squared, right? Then we can be able to change that into the sine squared theta. So I need to take out that 2 sine theta out as a common factor. Then I'm left with 1 minus the cos squared theta, which is what I need on top. So this will be divided by 2 sine theta times sine theta times the cos theta. I think you understand why I did what I just did now. I just have to separate the sine squared theta and write it as sine theta times sine theta so that these two can cancel. Then when I change the top part, I'll be left with 1 minus the cos squared theta over sine theta times the cos theta. But now I know that 1 minus cos theta is the same as what? Is the same as sine squared theta over sine theta times the cos theta. So I think now you know that the sine squared theta, we can definitely change that and write this as the sine theta times the sine theta. So that 1 sine theta, they will cancel with that sine theta. So on top, you're only left with what? With the sine of theta. So let me rewrite this. The sine theta times sine theta over the sine theta times the cos theta. So these two cancels, and this is equal to sine theta over the cos theta, which is just tan theta. Therefore, left-hand side is equal to right-hand side. Left-hand side equals to right-hand side. This is proved. So I'm saying that if this is not your method, and maybe the method that I do next, you will definitely understand that method, okay? All right. That was method 1. So if you understand method 1, please now wait for method 2. Let's see what we can do on the second method. So remember, we have 2, the tan theta and minus sine 2 theta over 2 sine squared theta. Okay, so now what we are saying is that the top part, this part here is just sine theta over the cos theta, and we're going to substitute that as 2 sine theta cos theta. Let's go and rewrite the equation. So this will be 2, what is this? This will be 2 sine theta over the cos theta minus 2 sine theta the cos theta, and everything is divided by 2 sine theta sine squared theta. So now look at what I have left. I'm going to indicate now. Look at this, move with me. I have 2 sine theta. I have 2 sine theta. Can I take that out as a common factor? Yes, I can definitely do that. So I'm going to write the 2 sine theta out as a common factor. Then I'll be left with 1 over the cos theta minus the cos theta. And everything is divided by what? Everything is divided by 2 sine theta times sine theta. So this is what happens. I separate the sine squared theta so that I can cancel this part. Then what do I have on top? I have 1 over the cos theta minus this cos theta. I'm going to write it as over 1. Then everything here is divided by the sine theta. So there comes the most interesting part, which has to do with LCD on top. Your lowest common denominator on top is the product of your denominator, which is just cos theta times 1. That's cos theta. Then you're going to take every term on top. You multiply every term by that LCD. The answer that you get, you divide by that LCD. Okay, let me write this down so that if you don't understand what I'm saying, maybe this can make sense. So now what I'm saying is that you take the cos theta, which is your LCD, you multiply the first term, which is 1 over the cos theta, close the bracket, minus the cos theta, you multiply that term, the cos theta, close the bracket. The answer that you get, you divide that by your LCD, which is the cos of theta. Remember, everything is divided by what? The sine theta. Nice. Then now, the 2 cancels, and then we left with 1 minus the cos squared theta on top. So this will be what? This will be 1. This will be 1 minus the cos squared theta, and everything is divided by what? The cos theta. Then I'm going to change this. Now, I know that the sine theta here is over 1. So I'm going to change the division into multiplication, but I multiply by the reciprocal, which is 1 over the sine theta. So I just have to multiply by the reciprocal. What is that equal to? This will be 1 minus the cos squared theta is just sine squared theta over the cos theta times sine theta. Then now, this will be the sine theta times the sine theta, everything divided by the cos theta times the sine theta. These two cancel, we just left with sine theta over the cos theta. Therefore, this is just tan of theta. Now you can conclude left hand side is equal to right hand side. Therefore, left hand side is equal to right hand side. Please, I don't want to see a comment where someone is saying that I don't prefer both methods. I don't understand any of those methods. No, that's highly impossible, because I think the second method it's nice until it comes to this part where you have to multiply every term by that cos theta and divide everything by the cos theta. But if you understand, I hope most of you will say the second method, because the second method is the easiest. We just have to follow the step. But the first one, there's too much confusion because of the inspection. If you, it's like saying we are working on this without an A. Oh, okay. The last question, guys. Please, let's work on the last one of this question paper. High order questions. Okay, hence determine the value of theta. This is too much. Now, the value of theta for the above identity to be undefined. So if I have A over B, for this fraction to be undefined, B must be equal to 0, because if I divide by 0, I get undefined. So to answer this, you're going to take whatever that you have there. You're going to say to the sine squared theta is equal to 0. Then this will be undefined. Then you solve for theta. Therefore, divide both sides by 2. You get sine squared theta 0. Then what will be theta? So theta, if I say sine theta, I can write this as the sine theta everything squared. It's equal to 0. Square both sides. Square both sides. Therefore, the sine of theta is 0. And the question is asking, hence determine the values of theta where theta is an element of 180 and 360. That will make the above identity defined. When you get here, guys, you don't have to do the sine inverse, what. You just have to know how the sine graph looks like. So the sine graph looks like this. It starts at 0, it approaches 90, then 180, 360. So look at this. This is 0. This is okay, this is 0, this is 90, and then this is 180, this is 270, this is 360. So you can see that from the graph there, at this point, 0, 0, at this point the sign is also 0, and at this point the sign is 0. So now they are asking, where is the sign 0? It's like saying, where is the y value 0? At the x values, it's at 0 when x is 180 and 360. So that's your answer, 180 and 360. So if the theta is 180 and 360, then we're going to definitely get undefined for that solution. And that's it for this question, guys. Remember, high order question. So this is where I'm going to stop for this one. And guys, please remember, leave those comments. Let me see if you guys really understand those methods that we discussed about.